Anyone have any questions about anything before we plow forward? I guess I should do a courtesy check of Piazza. My 515 class has been dominating that recently. Not a thing. All right. Well, excuse me, let's go ahead and just plow right into the next thing. So today I have assignment 15 for you. If I crack it open, assignment 15. This is an exercise in converting a sequence diagram to code. Our first real effort at doing that was in the JAWS project, and I hope you found that the translation, the reason for the assignment is I think people have varying levels of understanding of that process. For those who are coming to understand it, you should see that there's a pretty close to one-to-one relationship between what you're observing in the diagram and the code that you write. Let me go ahead and grab a copy of that tarball. It gives me directions for extracting it. So let me go ahead and do that. Let me change this. Oops, messed that up. And let me see, my tarball is in my downloads directory. Alright, so it creates an A15 directory, and there are quite a number of header and source files in there, and there's a make file. So I should be able to type make, and, oops, no I didn't, wait, there it is, there's the A15, I have to actually go into the directory. Let me pause and jump to the end game, which is what do you do when you're done? You do make clean, so you're going to have an executable and object files in there. Make clean is going to get rid of those because I'm not interested in those, just the source code. You're going to cd ... so you're going to go out of the A15 directory, and then you're going to create a tarball, another tarball out of the A15 directory, and that's what you'll submit. So you're going in here, you're modifying code, and then you're bundling it back up and returning it to me with the code filled in. The diagram that you're using for that is this diagram here. The names in the boxes represent objects. If you recall, the idea of sequence diagrams is that they're objects that are interacting that you're capturing. So we had Stormy and Lance and Starry and so forth, and so that's what's represented in blue. It's of course useful to know what abstraction or what class they belong to. So Fido is a dog. These are the classes that have been defined, these four classes. And now let me try make. So it isn't going to compile at this point because there are a number of places where you have to stick your code where it says your code here. And I believe I identify, you can easily open up the files and find where they are, but here's a short list of them. So let me try just a tiny bit of that. So I do need to add code to a15.cpp. And sure enough, here is your code here. A dog is created called Fido. A treat is created called Munchie. And we can see that indeed main is interacting with both Fido because there is this arrow here. And then it's a little hard, little non-obvious, but main is calling a function on dog and is providing an input parameter, and that input parameter is Munchie. So clearly main must have a relationship with Munchie in order to pass that as an input parameter. And sure enough, that relationship is right here. So that variable can be passed into a function, and of course we can interact with Fido because of that. So let me look at this. Main asks Fido to eat food. Now I may be a little bit unclear as to what that looks like, so let me bring open, what is that? Eat food is on the dog class, so I say dog.h, and there it is. There's function eat food. So it doesn't return anything, doesn't take any input parameters. I just have to tell a dog to eat food. In this diagram, the main function is telling Fido to eat food. So right here where it says your code here, get rid of that, Fido.eatFood. This is what I'm asking you to do. Go through this diagram and convert it to code. And I believe I have everywhere where you need to add code annotated with your code here. All right. And this is due, if you have a halfway grasp on this diagram, you should be able to knock this out in 15 minutes. However, some of you are struggling and so forth, so I actually don't have the due date till tomorrow evening. Are there any questions on what I'm asking you to do? This is once again just an assignment in class. You're welcome, in fact encouraged, to work with others. Everyone is expected to individually submit a solution since they're graded individually. All right, go ahead and have at it then. So do any of you have any questions at this point that you'd like to ask? Yeah.
From dog to location, like what's going on with the stain and then vomit thing?
So you're looking right here?
Yeah.
All right. So the observations I would make is that, one, there's an arrowhead going to carpet, so that indicates that the location class has to have a stain member function. Right? So visually, that has to be noted. And we can confirm that. We should be able to go to location.h and see that in fact it does have a stain member function. So let me come over here, let me look at location.h, and sure enough, it has a stain member function. So that's what that is saying. It has vomit in quotes there. If I look at the signature of this function, it does show that it does take a string as an input parameter. So it literally means that you provide the string vomit to that function when you call it. Now the next question is, well, how is that, where and how is that being called? It's being called from this line right here. And this line right here is the sum total of the eat food function. And which class does eat food belong to? Dog. And how do you know that? Right. Okay, you can look at dog.h, and we'll look at dog.h, but how do you look at it? And I'm just getting you to basically parrot back what I've been saying. What do you look at in this diagram to know that eat food is part of the dog class? The arrowhead is going to Fido, which is a dog. Yeah? All right, so we look at dog.h, and sure enough, eat food. So this behavior, all this stuff in here, has to be part of dog's eat food function. So let me go to dog.cpp. Here's the eat food function, and yep, so we got to fill in a bunch of stuff. Let me look at this first line. It says, take the variable stomach and add 10 to it. Well, all right, so maybe I do that. Where is stomach coming from? This means that somehow dog has some sort of relationship with stomach. Yes?
In our public, in the private section of our class for dog, we have an integer called stomach.
Right, so let me see. I want to put dog.h up here. Whoops. Dog.cpp down here. And so I just typed this, and sure enough, the dog abstraction has encapsulated together these functions with this data, and in fact, stomach is one of those pieces of data. So that's why that works. Now we get, so there's an if statement here, and then if that's true, it is going to call the stain function on carpet. So the way that line of code, we have some sort of if statement here. If it's true, reading this here, the carpet object, we're calling stain on it. The carpet object, we're calling stain on it, and based on this diagram, we're giving it the string vomit. How, and you, once again, you ask the question, well, carpet is a class and dog is a class. There has to be a relationship between dog and location. What is that relationship, and where is that relationship made such that a dog can talk to a location? And again, if we look up in the header file, we have it right here. Every dog has a location. In this case, it's called carpet. So that's has a relationship. A dog has a location, and so therefore the dog member functions can interact with that particular location. So that's that. That makes sense? All right. Yes?
What does the hiding place function do?
You mean the hiding place class?
There's the public function in the hiding place.
So let me bring that up. Hiding place.h. You're wondering about this function?
Yeah.
What kind of function is it? I should have actually put it up here. I actually added that particular function this morning quickly, so I guess I should make sure it makes sense. Here's the deal with this particular assignment is that all I'm looking for you to do is to translate the diagram to code, and the code doesn't make a lot of sense. And I was reflecting this morning thinking every semester people are getting different output and it's confusing them, and they're saying, why is my output not the same as this person's output? And I would say it's because the variables are all bogus. I'm not initializing anything. It's just an exercise in translating what you see in a diagram to code. I thought I would try and make some of that go away by providing values to some of these variables. So for example, hiding place is a constructor. I've crammed it all together on the same line. There's the actual body of the constructor. So whenever I create a hiding place, this function runs. This is the initialization list, which typically I've been putting down here. Hiding place, let me bring it up here. Hiding place has a private variable called depth, so that's why depth is in the initialization list. And all I'm doing is I'm generating a random number and doing mod 10. That's going to make the depth somewhere between 0 and 9. And that's all that's doing. I was just this morning threw it in there quickly to give it some value so that people don't freak out when it says 32,568 and wonder why, if they did it right. Any other questions? And in looking at it, I think I forgot to do it to, what was I looking at thinking stomach. Let me see, if I look at dog.h, yeah, you see I should have created a dog constructor here, and I should have initialized the stomach. So then I should have gone to dog.cpp and said dog initialization list for stomach, and I should have given it a random number as well. What is the if say? If the stomach is greater than 30. So maybe what I'd do is make that a number between 0 and 99, so that 30% of the time the dog vomits. So that I forgot to do that. You can either type that in or not worry about it. Anything else? All right, go ahead and continue pounding on it.